Good evening, everyone. Okay. Can everybody hear me okay? Great, thanks. And I also appreciate you coming out on such a rainy and windy and cold night to hear about the water census. Just starting out with a little levity, Dan mentioned that I went to the University of Nebraska and grew up in Nebraska. And of course, in Nebraska, you know, our saying is the N stands for knowledge. So, okay. I want to talk to you tonight about a program in the USGS that we call the National Water Census. And what is a water census? Well, first of all, it's part of our strategic plan. In 2007, we completed a strategic plan, the cover of which you see on the right-hand side of the screen there. And one of the major themes of that is a water census for the United States, quantifying, forecasting, and securing fresh water for our nation's future. Our objective as part of the water census is to place technical information and tools into the hands of stakeholders, allowing them to answer two primary questions about water availability. Does the nation have enough fresh water to meet both human as well as ecological needs? And will the water be present to meet future needs? And when we say stakeholders, we think of that very broadly. Our stakeholders are the public. They're also the water management agencies who struggle with these questions from a regulatory and planning basis and the like. They're also the biological resources managers and stakeholders, and the non-governmental agencies, organizations that care about these resources very deeply. Just to give you a definition on water availability analysis, what we're talking about there is the process of determining the quantity and timing characteristics of water, which is of sufficient quality to meet both human and ecological needs. That's kind of the core of the analysis that managers struggle with in determining, do we have enough water? Is it of adequate quality? Is it there at the times that we need it in order to satisfy these needs? I also want to just emphasize that water availability analysis is part technical information, but it's also socioeconomic considerations, legal, regulatory, and even political considerations that have to be taken into account. And at USGS, we deal with the technical information aspect of it. So we don't make determinations of water availability. We help others make determinations of water availability. And we do that through providing the technical information, the technical basis for those analyses. You'll hear me talk a little bit about an initiative called WaterSMART. And that's kind of a label for us and a brand. And so what is WaterSMART? It's a Department of Interior budget initiative on water availability and conservation that is coordinated out of our Office of the Assistant Secretary for Water and Science. That's the Assistant Secretary that's over both the U.S. Geological Survey and the Bureau of Reclamation. That individual is Ann Castle. And within the USGS, the main activity that's associated with the WaterSMART funding initiative is the National Water Census. Over at the Bureau of Reclamation, they actually have three major activities associated with it. First are river basin supply and demand studies that are designed to dovetail with work that we're doing in the water census. A program called Title 16 that provides funding for communities to do water reclamation and water reuse, such things as building desalination facilities or advanced treatment for wastewater so that it can be reused as a water supply. And then they also have their WaterSMART grants, which are conservation grants that are given out to entities to conduct water conservation activities. And they have broad goals associated with each of these. So one question also that often comes up is, how did we get to this point where we're talking about a national census of water in the country? And for those of you who have been involved in this field for some time, you may remember back to the 1960s and 70s when there was an entity called the U.S. Water Resources Council. And the USGS was a participating agency in the USGS, in the U.S. Water Resources Council. The council used to put out decadal analyses of water availability for the country, the last one of which was put out in 1978. The council was disbanded as an organization in 1980, and since that time there has not been a comprehensive national assessment of water availability in over 30 years. So we feel that it is really high time that a program like the Water Census gets underway. In 2002, Congress asked us to produce a national framework, so to speak, a national plan for how we would approach an assessment of water availability and use across the country. And we produced that, and it's published in our Circular 1223. In 2005, directly associated with the release of the recommendations in Circular 1223, Congress funded a pilot study on water availability in the Great Lakes. Now some of you might ask, water availability in the Great Lakes, a place that's got about 1/5 of the world's available fresh water, flowing fresh water present there. The chairman of our Appropriations Committee who commissioned these studies was from the Great Lakes Basin, so it seemed like a good place to do the pilot study. Then that study lasted for 5 years, and I will be talking about a number of the products that came out of the pilot study tonight. In 2007, our strategic plan of our agency came out, with the Water Census as one of the major 6 themes in the plan. In 2007, also a report came out of the Office of Science and Technology Policy, their subcommittee on water availability and quality, and it outlined the roles of all federal agencies on working on water availability and identified activities in the USGS as promoting, in terms of promoting the need for a water census. Probably the most significant thing that has occurred in the last decade on getting us to where we're at now and last year on a water census is the passage of the Secure Water Act. This happened in 2009. SECURE, in this case, is an acronym. It stands for Science and Engineering to Comprehensively Understand and Responsibly Enhance Water. And cute acronym, sometimes hard to remember. Also in 2009, the National Research Council released a report called Towards a Sustainable and Secure Water Future. And that report also highlighted the need for a national water census. And then finally, in 2011, the President included in his budget request to Congress the WaterSMART Initiative to jumpstart activities both in the USGS as well as the Bureau of Reclamation. So, how do we go about accounting for water availability from a technical perspective? Well, we use something called a water budget. And a water budget is really very similar to the budget that you all have for your finances at home. It accounts for all the inputs and outputs from a given watershed, just the same as your family budget accounts for all the inputs and all the deposits and withdrawals from your account. And it looks at how much is in storage or how much reserve you might have in your accounts and the types of factors that influence it. So a couple of, just to highlight a couple of those aspects, the green arrows here represent exchanges with the atmosphere. Precipitation coming into the watershed, evapotranspiration going out, the amount of water that's evaporated or transpired by plants and trees. The blue arrows represent exchanges of water within the watershed or between the superficial system and the groundwater. So it would include freshwater inflow and outflow, groundwater surface water interaction, exchanges between deep groundwater systems and shallow, and the flow through the groundwater system. And then finally, the gray arrows represent man's influence on water availability, our withdrawals from groundwater and surface water, and our return of some of that water back to the land surface through such things as wastewater return flows, agricultural return flows, or irrigation. So our effort in the water census is to start quantifying each one of these exchanges. We can write simple or complex equations that represent each one of these exchanges in the environment. And we can look at those interactions either on very large scales or very small scales, or over long time periods or short time periods. And our effort in the water census is going to be to look at it on relatively small scales and short time periods and aggregate that information up. So let's look at that a little bit. First of all, we want to deliver a nationwide system that allows users to access all of this information about water supply. And when I say the supply side of the equation, I mean all the things that bring water in, precipitate or affect water on the natural landscape: precipitation, evapotranspiration, storage in reservoirs, lakes, ice and snow fields, surface water flows, groundwater flows, including things like recharge rates and changes in water levels in aquifers. Then we also want to look at all the factors on what we call the demand side of the equation. How is water used? And one certainly very important aspect among those are the ecological water needs. How much water do we need to leave in the environment to maintain a healthy ecosystem? As well as, what are the human uses of water? The withdrawals, the return flows, how do we consumptively use water, and what are our run-of-the-river uses? So let's talk a little bit about how we go about delivering that information. Well, today, you can download this map off of our USGS website. If you go to our WaterWatch homepage that's listed right here at the bottom, you can download the map and the data behind this map that gives you estimated monthly runoff for every Huck 8, and I'll explain what that is in just a second, for every watershed at the Huck 8 level throughout the entire lower 48 states. And in not too long a time, we'll be able to include Hawaii, Alaska, and the Caribbean islands in this as well. But today you can download this map, and it gives you estimated runoff for every one of those watersheds throughout the country. And you can not only download that for this month, you can download it historically for every month back to 1900. But let's say that if you're working on water management issues and you really need water estimates at a finer scale, and monthly information isn't good enough for you, you need daily information, you might want to have this enhanced. And that's part of what we're going to do under the water census. So let's envision that under the water census, you were able to download data on precipitation, runoff, base flow, evapotranspiration, recharge, changes in surface water storage, down to a watershed equivalent to 35 square miles, every 35 square mile watershed across the country, and not only on a monthly basis, but daily information on this, of all these factors that influence the water budget. That's one of the goals that we're shooting for under the water census. And I'll be talking about the activities that we have underway to get there. As well, you want to be able to work with this information. So we will be designing and building a website interface similar to the web interface that we use in our StreamStats program. Some of you may be familiar with that program, where you would be able to select an area on the screen, point and click, have the system automatically delineate the watershed above that point, and then generate all the information about the water accounting components. and deliver that information to the website for you. Then you'd be able to work with online tools to construct your own water budget of that area, and maybe even change some of the parameters to see what kind of influence that would have. And then also access information about trends in those water availability parameters going back 30 years. That's the system that we are designing. Now we have to do various things in order to accomplish this, because even though we run approximately 7,700 stream gauges across the country, that by no means gives us estimates of flow down to the scales that we're talking about. So one of the things that we're doing as part of this program is developing a means of estimating flows at ungauged stations across the country, so that any place on the landscape you'd be able to point and click and get an estimate of the flow, not just flow characteristics or flow statistics, but actual daily flow values for that piece of the landscape. We're also working on similar efforts for evapotranspiration. And as I mentioned, evapotranspiration is the amount of water that evaporates off the landscape or is transpired by plants. And those of you familiar with it, I'm sure you know that in many places throughout the world, evapotranspiration accounts for more than 50% of the rainfall. So if you think about that, rainfall is our source of water. It's our source of fresh water in this country and throughout the world. And about 50% of that or more in most places in the world evaporates off or is transpired by plants into the atmosphere. So this is a very important aspect of the water budget to be able to quantify. We're working in two efforts on evapotranspiration. One is to just look at, as a broad landscape feature, how much water is evaporated off the landscape for an entire watershed. But then another aspect of evapotranspiration is we enhance how much water evaporates where we irrigate agriculture. We're bringing water in, we're importing it to an area, we're using it to irrigate crops and grow crops, often in areas that are arid, where the ET rates are relatively high, and those plants are transpiring water off that. We also need to get an estimate of the amount of ET that's associated with irrigated cropland, because it's an important part of the water budget, and it's also an important measure of the consumptive use associated with irrigated agriculture. Another activity that we need to do to be able to deliver this information is we really need to enhance our understanding throughout the nation of water use. And here I'm talking about human water usage. How much water do we withdraw, transport, consume, and return to the environment? And we're going to be using new methods for estimating water use across the country, more use of statistical models like regression models. We are going to be developing models of how we can relate water use, human water use, to land use characteristics. And ultimately what we want to be able to do is we want to develop the ability to track the drop of water that humans use from the point where it's withdrawn until it's ultimately returned to the environment. So what are some of the things we need to do in order to do this? Well, first, I want to just introduce this concept of what we call conveyance and water use tracking. And envision that this is a simplistic watershed view here. And someplace within the watershed, we pump water out of the ground and we use it to irrigate cropland. Okay? Now, because we're irrigating that cropland, we're enhancing the amount of consumptive use. So that's going to reduce groundwater or surface water resources as a result of that activity. We need to be able to quantify that. In other places, we may establish a community water system and pump that water up to a piece of landscape where there's a residential development. And let's say it's residential development that's on unsewered land where they're using septic systems. And that residential piece of land overlaps a drainage basin. So some of that water ultimately gets to return back through septic system flow, but the part that's out of the basin is now a out-of-basin withdrawal to the flow at that gauging station. And then we also have the circumstances where we pump water to sewered land, and the wastewater, after it's treated, is discharged wholly outside of the basin. And that's a complete depletive withdrawal to this basin. So our water use program in the country has to be able to characterize all these kind of conditions and account for the human infrastructure for moving water around. This can get to be very complex because, in this schematic diagram of a water supply system, you may have a surface water source and multiple sets of well fields in various parts of the system that ultimately distribute water to the population where they use it, and then that the wastewater will be collected and discharged at another location. So this is the whole idea of being able to track water through the human infrastructure. As I mentioned, this can get to be very complex. In this diagram that's done in the hydrologic unit code 6-digit basin for the upper Colorado demonstrates just how complex that can become. Now, just to orient you, over on the right-hand side here would be Rocky Mountain National Park and the Continental Divide. Okay, so the city of Denver is right off over here. And then this watershed stretches over to about Grand Junction, Colorado. And so we have all the landscape in between. And the dots that you see on the map are the 12,500 irrigation diversions that occur within the Colorado River Basin. Some of those carrying water outside of the basin to satisfy irrigation needs. And just zooming in a little bit on the Vail, Colorado area, you can see the number of diversions and the complexity that occurs with this. And as I mentioned, these are just the irrigation diversions. It doesn't include water use for other types of needs. So what kinds of water use needs do we include in our analysis? Well, this bar chart shows the magnitude of freshwater and saltwater withdrawals for various human uses across the country, and they're in ranked order. 49% of all the withdrawals in this country are used for thermoelectric power generation. That's a lot of times surprising to people, but extremely large volumes of water have to be withdrawn for thermoelectric power generation. Now, in the case of once-through cooling facilities, much of that water, the vast majority of it, is returned back to the stream unevaporated. But in the case of facilities that have cooling towers and the like, much of the water that's withdrawn will be evaporated. It depends largely on the technology that they use. 31% of all the water that's withdrawn in the country is used for irrigation. And irrigation is the 800-pound gorilla when it comes to consumptive use, because the vast majority of that water is either evaporated or transpired by plants. So these two categories alone account for 80% of all the water use in the United States. 11% is used for public supply. So this is the water that we use in our homes, plus the water that's withdrawn and delivered to industries and commercial establishments within the service area of those public community supply systems. And then self-supplied industrial water accounts for an additional 4%. So these four categories, 95% of all the water that's withdrawn in the country are from those four categories. Then we have four smaller categories, including self-supplied domestic, that's everybody who has their own individual domestic well, livestock, which is less than 1%, mining, which is about 1%, and aquaculture, which is 2%. Let me just go back briefly. We've been accumulating information on water use at the USGS for a very long time, since 1950. And every 5 years we put out a report called the Compilation of Water Use in the United States. And I just want to give you a quotation from a National Research Council report on the significance that they see in this data that we produce. This is a direct quote. These reports, estimated water use in the United States, have been published every 5 years since the 1950s and are one of the most widely cited publications of the USGS. So it's very significant activity and effort that we have, and one that we need to even do a better job on if we're going to deliver a good water census. Part of what we do with this data is we are able to look at trends in the country. And I think this is a very interesting chart, kind of surprising to a lot of people to know that this line is our population growth since 1950 through 2005, and of course population is along over here on the right axis. On the left axis are hundreds of billions of gallons of withdrawal. And you'll notice that it was rising very rapidly until about 1980. And then it dropped and leveled off during that time. So actually, over this entire period, our per capita use of water has actually decreased since 1980. And this is due to a variety of factors, including regulatory programs that were put in place, water conservation activities, industry cutting back on the amount of water that they use so that they produce less wastewater that would have to be treated and the like. I want to go on to another type of water use, a very important type of water use that people often don't think about. And it's become much more present in our thoughts in the last 2 decades, but prior to that got little play, a little accounting in our water availability analysis. And that was the water needs for wildlife and habitat. We refer to this as ecological water science or ecological flow science. And it's a rapidly developing research area throughout the world, and one that we're very interested here in the USGS. Some of the things that we want to be able to provide to the country are classification systems so that we can classify our water bodies as to their hydroecological type. What type of aquatic environment do our rivers support, and what types of flows support that? We also want to produce tools and data that allow managers to systematically assess the ecological effects of changing the hydrology. When they alter it, what happens? Do we still have the same species there that we did before? How does that change? And we want to assist users in developing water alteration, flow alteration, ecological response relationships, which are kind of the building blocks that people use for ultimately setting ecological flow objectives. And again, we at USGS don't set those flow objectives, but states are very active and interested in this process today, along with non-governmental organizations like the Nature Conservancy. Okay, other things that we have to do in the water census. We need to expand our activities in assessing groundwater's role in water availability. What we do throughout the country is we are systematically analyzing what we refer to as principal aquifers. These shaded areas on this colored map represent the 63 principal aquifers that account for the vast majority of groundwater usage throughout the country. And actually, the top 30 of those, the 30 principal aquifers, if ranked in water use order, account for 94% of all the groundwater that's used in the United States. So understanding what happens in these three-dimensional systems is an extremely important part of the water census, and how that water is moved to the surface, how it's used, and how it's disposed of. So we need to know things such as recharge values, groundwater yields, changes in storage, trends in groundwater indices, in groundwater and surface water interactions, to name a few. And we will do that through strengthening the USGS programs for studying groundwater availability. Another issue that we're called to do as part of the Secure Water Act is Congress told us we would like to know about the nation's brackish groundwater resources. So those are all areas of groundwater throughout the United States that are too salty to use directly, either for public supply or in many cases even for irrigation or livestock purposes. And they're quite widely distributed throughout the country. Most times these resources are deep, and the color coding is showing you the depth to saline water in these various areas. They tend to be areas that we don't know a lot about from a water supply perspective. Most of the people who drill into these are looking for energy supplies. They're looking for oil, or they're looking for natural gas, and that's where a lot of the data on these has historically come from. So Congress has asked us, we want to know the locations of the resource, the hydrologic and water quality properties, and currently who's using them. And there are communities that are using saline groundwater and treating it for their water supply, but of course that tends to be a very expensive proposition. We also, of course, want to know the issue about quality. What is water quality's role in water availability? How does water quality impairment limit our access to water? And it doesn't have to be so bad that you can't use the water. It just has to be bad enough to make it more expensive. And all of a sudden you're influencing decisions that people make about water availability due to water quality. So we want to use the strength of the USGS water quality programs to determine the degree to which water quality impairs water availability, define the main compounds that are important to analyze, relate water quality to water use and return flows, and look at the trends. The last aspect that I'm going to talk about tonight relative to the water census is we've developed a notion of conducting focused water availability assessments in watersheds rather than tackling the entire nation at once, so that we can learn certain things about how to relate some of this information and integrate it together to give us a comprehensive picture of water availability. And in basins like the Colorado River Basin, we've been working with state, local, and regional stakeholders to define a set of technical questions that are important to understand about these watersheds in order to better understand water availability. And then we bring the various programs of the USGS to bear on answering those questions and developing a comprehensive picture. We have three basins that we're concentrating on right now: the Apalachicola, Chattahoochee, and Flint River Basins in the southeast. It's the last time I'll say it in longhand. It's the ACF Basin for short. And for those of you who don't know where that is, that's the Atlanta area and south of there. The Colorado River Basin and the Delaware in the northeast. And there are some important aspects of these basins, of why they were selected, and what about water availability stresses makes these basins good areas to study. In the Delaware, even though the Delaware River Basin represents 0.4% of the land area of the country, it delivers water to 15 million people, 5% of the U.S. population. And a lot of that is because of out-of-basin withdrawals. It has had 2 Supreme Court decrees dividing up the water amongst the various parties that use it. It has abundant endangered aquatic species that are at risk within the basin, and you may have read recently with the development of the Marcellus natural gas shale play, there are looming issues with regard to natural gas development in the upper basin. In the ACF, there's been, I'm sure you remember the Georgia, Florida, Alabama water wars, the competition over the resource. In particular, a tug of war between public supply and agriculture in the basin. Much state litigation that's still going on today. In the Colorado, it's got a very fast-growing population within the basin. Lots of energy development. It's the backbone of hydropower for the Southwest, and we've had declining river flows over the last 15 years. So that is kind of my overview of the water census and our plans, I want to give you a little picture of the work that we did in the Great Lakes, and then we'll open it up for questions. So we conducted this pilot study within the Great Lakes Basin, and that's a aerial photograph of the basin, of course. All of the products that you're going to see are available through our website, water.usgs.gov, water availability, Great Lakes. This study and all of our studies, we feel that it is our obligation both to look at the national emphasis associated with it, but also provide the regional focus and what kind of information can we deliver that's relevant and usable to regional and local water managers and biological resource managers. We developed methods that were applicable to the national level, but we responded to Great Lakes issues, and some of you may know that there's a Great Lakes Compact that has as one of its focuses water availability. So a couple of the products that came out of that. Well, one thing was the stakeholders within the basin wanted to get a much greater current and more accurate definition of regional recharge within the basin, because much of the water that's used within this basin does not come from the lakes themselves. It comes from groundwater resources or small streams on the landscape where that water is being delivered. So understanding how recharge varies across the landscape was a very important factor. Another one with regard to groundwater are how are the groundwater divides within the basin shifting over time as a result of pumpage. Now, just to orient you on this, of course, here's the Chicago area. This line right here, this dotted line that comes very close into the lake and then back out, that's the surface water divide for the basin. The historical groundwater divides were a little bit further out, so groundwater on this side was flowing towards the lakes, but as a result of a lot of the pumpage within the Great Lakes Basin, we've been pulling those groundwater divides further to the west. And with that, we changed the flow regime to the lakes. It was important for us to document that, and that has become part of the regulatory considerations that the Great Lakes Basin uses. You may have read about some of the interstate lawsuits that were happening over the Waukesha area. Another issue in the Great Lakes is, just how have the natural trends manifest themselves over the last 50 years. And interestingly, the gold circles here are stream gauges where base flow has been increasing over the last 50 years. And you'll notice that in the vast majority of the places depicted on this map, stream flow is actually increasing over time. Well, that can be associated with a climate signal. A climate signal in which more water is evaporating off the lakes and falling as precipitation on the landscape. And this is an issue that we're looking at very carefully. Stream flows have been showing a distinct increase over that 50-year time in most parts of the basin. Another issue that's been very present is lake level variability. Some of you may have read that within the last decade, water levels in Lake Superior have fallen so low that ore boats carrying ore through the Sault Ste. Marie Canal have to go through partially loaded because there's not enough draft, not enough hydrologic stage to get those barges through fully loaded. Likewise, lake levels have been dropping in the Lake Michigan and Lake Huron system. So the stakeholders within the basin said, we'd like to see how lake level variability within the last measured record, and that's this little part right over here, that's the last 150 years, relates to the long-term paleo record. So we put together a 5,000-year history of lake level variability in the Great Lakes Basin. And you can see that actually, in current time, we're pushing the bottom of the limit in terms of where lake level variability has been since just post the last ice age. Another issue in the Great Lakes that's very important to them, they manage based upon consumptive use in the basin. And if you are going to develop a new project in the Great Lakes that has more than 5 million gallons per day of consumptive use, your project has to be elevated to all 8 governors and 2 provincial provincial governors in Canada for a review before that project can be approved. So a very important issue was, what are appropriate consumptive use coefficients to be used in the basin? How do theirs compare with climatically similar areas throughout the country, and how does consumptive use vary on a seasonal and monthly basis? And so this was part of the products that we developed in the Great Lakes. And then, of course, we put together an overall water budget for the entire system. And just a couple of highlights that come out of that. Of course, we assessed groundwater as a resource, and groundwater within the Great Lakes system is on the magnitude of adding an entire another Great Lake. And of course, it's in the tens of trillions of gallons flowing in the system. The annual outflow of the Great Lakes is 1% of the storage. So the amount of water that's going out through the St. Lawrence Seaway represents about 1% of all the water that's stored in the system. Water use throughout all the Great Lakes amounts to about 65,000 cubic feet per second, a relatively small amount of that annual outflow, and the consumptive use is about 3,000 cubic feet per second. Now that just puts it in perspective in terms of an entire watershed the size of the Great Lakes. Does that mean that water use and consumptive use are not important? Absolutely not. Because we not only, as water managers, need to look at the entire system, but how that plays out within our local watersheds. So this is just giving you an overall picture. As I mentioned, our reports through the Great Lakes study are available on this website. This represents the approximately 15 technical products that were produced as part of the Great Lakes study over the 5-year period, and I invite you and urge you to go and take a look at the Great Lakes website and the work that we've done there. And I just want to conclude by saying, again, our objective as part of the water census is to place technical information and tools into the hands of our stakeholders defined broadly, so that they can answer the questions that they're facing about water availability. Again, my name's Eric Evenson. I'm the Water Census Coordinator. I am located in beautiful Trenton, New Jersey, about 3 hours north of here. And there's my phone number and my email address, and I'd be happy to answer any questions that you have. Thank you.